Hi folks, Tom McNamara back here for our course in Prep for College Math. In the previous couple of videos we've been talking about multiplication of whole numbers. In this video we're going to go over the pencil and paper algorithm for multiplication. Don't be afraid of this word. Algorithm is a process or set of instructions for accomplishing a task. So an algorithm is a step-by-step procedure that you can follow that will complete the task. And we'll go over the pencil and paper algorithm for multiplying whole numbers. So we'll do a couple of increasingly complex examples. Okay, now, in the previous two videos we've talked about certain scenarios where you can get away with less work without doing that. Okay, so for, I don't know, a quick example, if I were to do, let's say, if somebody asked me to do 40 times 6, I don't really need to do the pencil and paper algorithm because I know 6 times 4 is 24. 6 times 4 is 24, 240. That 0 just kind of comes along for the ride. Okay? So no real need to do the pencil and paper algorithm in that situation, but sometimes you really just can't get around it. So something like this, 863 times 9. Okay, well, no multiples of 10 here, so remember when you're doing multiplication, 10 is your friend, pretty easy to multiply by 10, but here we don't have that, just gotta power through the standard pencil and paper algorithm. 9 times 3, 27, so we write down the 7, and we rebundle or carry a 2 over to the tens place. 9 times 6 is 54, plus the 2 that's up there gives us a 6. Okay, once again, you have got to know your single digit multiplications cold. You cannot do anything without knowing that multiplication table by heart. Okay, so 9 times 6 is 54, plus the 2 gives us 56. Carry that 5. 9 times 8, 72, plus the 5 gets us 77. So our answer there is 7,767. Okay, let's go ahead and do this one right here. 73 times 59. 73 times 59, okay? So, we're going to start by kind of ignoring the 5 for right now. We're just going to concentrate on doing 73 times 9. Okay, 3 times 9, as before, 27. So we write down the 7, carry the 2. 9 times 7 is 63, plus the 2 gets us 65. Okay, so 6, 5, 7 right there. And now we're going to multiply 73 by 50. Okay, now multiplying by 50, that's a multiple of 10. Remember, 10 is your friend. You just tack a 0 onto your answer. So I'm going to concentrate on doing 73 times 5 and just have this 0 placeholder over here, because we remember we're not really multiplying by 5, that's a 5 in the tens place, so we're multiplying by 50, but that's easy because we just need that extra 0 placeholder right there. 5 times 3 is 15. Put the 5 down there, and we're going to carry the 1. Now forget about this 2 for right now, okay? We don't need to add that 2 in, we need to add in the 1 that we got from 5 times 3 being 15. 5 times 7 is 35, plus the 1 is 36. And now we add these two numbers that are already in columns. Okay, so 7 plus 0, of course, 7. 5 plus 5 is 10. Carry the 1 there. 1 plus 6 is 7. Plus 6 is 13. Carry the 1. And we get 4,307 from our multiplication. Okay, so I'll do one more example to refresh your memory on this standard pencil and paper algorithm. And we'll do this one, two 3-digit numbers. 916 times 409. Okay, once again, we'll start over here in the ones place. We're going to ignore these for right now. We're going to concentrate on multiplying 916 times 9. Okay, 9 times 6 is 54. So we carry a 5 over to the next place. We rebundle the 5 groups of 10 and put that up here. 1 times 9, of course, is 9. Plus the 5 is 14. Rebundle a 1 over to the next column. 9 times 9 is 81. Plus the 1 is 82. Okay, so 8244 right here. Now, in my tens place, I actually have a 0. Now, 0 times anything is 0. So, that really isn't going to contribute anything. I guess if you want, we could put in a row of just zeros like that. Okay? So we'll go ahead and do that. Now, when we're doing this, okay, this 4 is, of course, in the hundreds place. So it's not really a 4, it's a 400. Okay, but if we're multiplying by 400, that's just as easy as multiplying by 4, provided we put two placeholder zeros at the end. Whenever you're hitting something with a multiple of 100, you're going to get those two zeros at the end. So we'll do that here, and then concentrate on multiplying 916 times 4. Okay, so 4 times 6 is 24. Bring the 4 here, and then carry the 2. We're forgetting about the 5 now. The 5 doesn't matter anymore. The 5 was from when we were dealing with the 9. It's gone now. Dealing with the 4 times 6, carry that 2. 4 times 1 is 4, plus the 2 is 6 in this column. And there's nothing to carry, right, because there's no tens digit. 4 times 1 is 4, plus the 2 is 6, single digit, nothing to carry over. And finally, 4 times 9 is 36. Remember that 1, that was a holdover from before when we were doing 9 times 9, and then we were adding the 1 up here, right? That doesn't affect the 4. And now, once again, we're adding these. Okay, we got 4, 4, 6, 14, carry a 1. So 374,644 for this product, okay? And remember, this is just a reminder of how we shift everything over when we're multiplying by higher places, okay? The ones place, we start right here. The tens place, 1 placeholder 0 and start here. The hundreds place, 2 placeholder zeros, and we're starting there. And then once we're done with all the places in this bottom number, we add, okay? And that's your standard pencil and paper algorithm for multiplying whole numbers. It works every time. Sometimes it can get a little tedious, but it will get you the answer, okay? And that's what an algorithm is, a set of steps that will accomplish a task.